Hello and welcome to another episode of Modular in a Week. Today we're gonna make a much simpler sequencer. So we wait a while before I continue with a few things more on the Baby 8. A better panel and front panel, for example, would be nice. That's in the works, so I have to get back on that. But the sequencer we're going to do today is this little thing here. It's on a breadboard right now, where I'm going to put it on a proto board and add a few more debound circuits and stuff like that for buttons. But what this is the chip is 4031, so it's a 64-bit shift register. And what it does, so you have a clock in, and then you tap the beat. So it's a tap sequencer, tap looper, and then it can play that around. So this little circuit right here, one channel, but one channel that beats most of even modern sequencers or drum machines, stuff like that. Most are just 16 steps, some are 32, very few are 64. This one is 64, so we have 64 steps. This gives loads of possibilities in a musical sense, I think. So it's a really interesting circuit. I am going to do a dual one, at least. Maybe I can get more on one panel, but definitely two. So I can have two step sequencers to play along with. Before we go into building this and looking at this, I want to say thank you to my Patreons who support this work and all the other stuff I do around here over on Patreon, and get a few extra perks for that. And you can too, of course, if you want to see more of this stuff, just behind the scene and stuff like that. You can head over there and see some other content over there. With that said, let's go and build this one. So if we begin with the design that A Magic Pulsewave did, this is what you saw on that breadboard. It is just the 4031, and then you need a clock source. So I put a input jack here, and then you need a quite a special switch. Push buttons isn't usually normally on, but this needs to be a normally on push button that when you push it, it turns off, and that is to clear the pattern. I'll show that in a bit. And then you need a push button here, a normal one, to tap the beat, and the output goes out from pin 6. This is all you need if you want to make it really simple. But of course I had to go and make it a bit more complicated. So what we have here for these, so I made a dual one because I can just fit two of these, a 4081 and a TL074 onto one chip. So the TL074 is used over here as 4 comparators and for the clock input, and we have voltage dividers that gives us around 1 voltage threshold. So any input on the clock or on the debound switch larger than 1 volt will give us a pulse. So that makes it really sensitive, and because then it works with all our different clocks that we've built, even though they don't all output that large of a voltage. I also have the debound switch over here and here for the tapping, so that is good and nice, and no double taps is happening. Both outputs goes into 2 AND gates each, after that in the 4081. One is just connected to both, like a buffer that then outputs that to something I call sequence output or sustained output. And that's what I mean is that if you hold the button and keep it pressed, then you won't get a chopped up beat for each step. You will get a whole note for whatever duration you push the button. The other one, however, goes into an AND gate together with the clock. So that one is, I call it a gated output. So it's chopped up with the clock. So this is better if you want to make really simple hi-hats, for example. You just hold the button in and you would get whatever divisions that on the output that you have, that you press, and with the clock. I also, as an afterthought, added LEDs both for the clock and for the output of the gate in the 4031, and that is because it's good with visual cues for when you have a press and when you have a clock and stuff like that. And this schematics is of course available in the Dropbox folder that is in the description. So let's look at this in action. And here you see the PCB that I did. So it's the proto board, and I just got to fit 4 of these circuits on one of these with 1 row of spacing on between each IC, and the helping components on the sides. And the panel is not the finished one. This is just some temporary stuff. But if we look at the panel, it looks like this. And you got all the tabs, the clear, and the inputs and outputs. And also there's a tap input on the latest design, which isn't in the schematics in this video. I'll try to add that in the final schematics. And that's if you want to add taps from another device. Here we have the 4031 tap looper in a makeshift panel, because I haven't gotten the real panel yet. There's one push button for the reset and one switch for the reset. Just trying those out, plus I only had one of these special switches which is normally on and the connection is broken when you push it. So we need to begin by getting a clock in here. And I've played around with this a bit already, and I have figured out that it works best if you hit the notes better if you have a clock that is, so if we look up here, a clock that is inverted. So I take the divide by 2 and I actually invert that signal in the quad gate inverter to get a gate that is just a wee bit after or before. It's off center, so that makes it easier to tap the correct beat. Let's begin with doing a bass drum maybe. An interesting thing is that it actually keeps, if you break power, it remembers the last pattern you did and keeps that in memory, so that's good. We also need a metronome, I think, so let's add one of those. Divide by 8. So let's clear this. And I think it's cleared there. So now we can, let's do this classic bass drum. Didn't do I didn't get that quite right, but we have a bass drum anyway. For demonstration purposes, it's good enough. What we can do now is so this is the sustained output. I'll show that more when we are using it for melodies instead. But for drums, we can take the gated output as well as the bass drum, and we take this to the percussive noise, for example. Let's see if we can get some. Need to adjust volumes here. So if we do a bass drum where we hold the key in a bit more, we will see double and triple taps on the hi-hat with this. And now we get let's see, do you see that? There, you see it, that we get more with double taps with because the clock on this one chops up the long notes I'm pressing. And let's get something else going, some kind of high or snare with the XOR bell. This is what happens. I had it left in, this is a switch, so it was still in clear mode, so it just plays once and then it's gone. And as an extra thing, we can take the hold or sustained output, the chopped up output of the snare, and we can also add that to the CV-in, the K CV-in of the trigger of the hi-hat. See if we can hear that. So only the hi-hat here. So with just 2 channels we can actually play 3 or 4 variations of instruments. Alright, let's do the same thing but with melodies now. So I have the down here is the very rudimentary BB-8. So if we listen to that, it's just playing a melody right now. So we take out the clock and we take the clock from this one instead. So now we tap a more interesting beat. Bam, 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 bam. The thing is, I held the notes quite long this time, so if we divide this in the passive multiple, so we can't divide in a multiplier, we multiply it. So we also take it into the Vectral VCA. Let's see if we can get that in frame as well. That's over here. We run it through. Now we can get long tones and short tones, depending on how long we pushed the button. If we instead take the gated output, we get double clicks. Right, now we get that on the melody as well. So if we only take the double tap on the CV of the VCA, now it's just short tones and they're chopped up. And with that, this awesome little module is done. And even with my additions to the schematics, I really think this is a really easy build, and I can really recommend that you build it. To play it, however, is a bit difficult, and the trick with the half-step clock input helps a bit, but once you build it, I guess you need to train a bit to get the patterns right. Even though the patterns doesn't get quite right, I think it's very modular in the way that modular is supposed to be here and now, and some bit of chaos or randomness to it. That you have all this and you want to make something and you do it and it doesn't get exactly what you want, but it becomes that it becomes, and that it is gone. The second you press the clear button, that part of the pattern is gone, and that's part of the modular thought, I think. It's very nice, very now, very mindful. So yeah, with that, go and build one of these and make some fun music with it, and I'll see you in the next video. Take care. Bye. Subscribe and all that, which I always forget in every video. When I say bye, I remember that you should subscribe and you should press the bell button and all that. So, goodbye again.